Homework pressure? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
Question 5 states that a beam of particles is directed at a 0.015 kilogram tumor. There are 1.6 times 10 to the 10 particles per second reaching the tumor, and the energy of each particle is 4.0 MeV. The RBE for the radiation is 14, and the question asks to find the biologically equivalent dose given to the tumor in 25 seconds. So we're told a lot of information. So the best place to start is, I think, to look at the equation. Well, we want to solve for BED. So what equation do we know for BED? The most common one, that the BED is simply the absorbed dose times the RBE. RBE times absorbed dose. So looking at this huge list of givens to us, we know that the RBE is known, so I don't have to do anything with that. However, the dose to the tumor is not, so we need to do a little bit of investigation to solve for that one. We are given a couple of rates. However, we have particles per second and energy per particle. So that kind of tells me that we need to look at those in terms of energy. So since we already know the RBE, we'll just carry this term along with us. And we know that the absorbed dose is simply equivalent to the energy absorbed per mass. We know the mass. However, again, we don't know energy. So the first thing I'm going to do just for a second is going to take this RBE and pull out the mass term. If we look at total energy now, we know we're told actually a couple of things, so maybe this will help. If we know the energy per particle, so Q over N, we know that the amount of particles per second, so we can multiply that by N over T. And we also know how long the person will be irradiated for in terms of seconds. So if you look at this term here, not that I will do this, just to double check my own work, N's would cancel out, our T's would cancel out, and we do see that this whole term in brackets is equivalent to Q. So this equation in brackets is a good substitution for what we have for Q. And we note Q over N, N over T, and T are all known to us. So from this, we can calculate our BED. So we can do that now. We'll plug in some values right now. So our BE is given to us as 14 over the mass, 0.015 kilogram. Multiply that by our term in brackets here, Q over N, 4.0 MeV per N, times the number of particles, multiplied by our particle rate of 1.6 times 10 to the 10 particles per second, multiplied by 25 seconds. So while this may first seem perfect, we have all the values, let's plug it in and go. One slight issue we have is that if we want our BED, we need our dose or our term on the right side to be equivalent to, of course, to be rem. In its current form, it is very much not. We have MeV, we have kilograms on the bottom, so that tells me initially I need to convert this right side. Well, we know if we can convert our dose into rad, multiplying that by the RBE gives us rem. So this is what we need to do to our dose term, our Q over M. So what we need to first do, we need to convert this right side into rad. So by doing that, we first have to go from our MV to joules. So we know the conversion is 1.6 times 10 to the negative 13 joules per MeV. And doing this, we can note that, we'll just check a couple of units actually. Seconds cancel, a little too messy, too many units here. MeV will cancel out with this term, and we are left with joules per kilogram, which is gray, which is a good start because now we need to go from gray to rads. And we know that joule over kilogram is 1 gray. So to get rid of that, we divide by 1 gray. And we know in 1 gray, there are 100 rads. So now this should be everything. Just to double check, gray cancels out our joules per kilogram. and we have a value for RBE multiplied by a value in rad, which meets our condition we stated previously, and we can find that the total biologically equivalent dose in rem to two significant figures is simply 2.4 times 10 to the 4 rem. And there you go. Question 5.